Good morning, Aspen. Is everybody here for exercise in the brain? Yes? Okay, great. Hello, my name is Dr. Wendy Suzuki. I'm a professor of neuroscience and psychology at New York University and also the dean of the College of Arts and Science at New York University. And I want to start with sharing with you the official CAS greeting. This is what I tell all freshmen when they see me in the street, come up and greet me with this. And a little shout out to Hugo back there. Hugo, can you wave? Here's our 2024 CAS grad. He knows what I'm about to say, and he also works for the Aspen Institute now, so that was really nice to see. So here's the official CAS greeting. You have a beautiful brain. So I want you all to turn to somebody at your table or next table and tell them, you have a beautiful brain. Okay, beautiful. So today we're going to talk about the astonishing effects of exercise on your brain. And I want to start with a challenge for all you amazing Aspen participants and speakers out there. And here's your challenge. There's actually 3, and then I added a 4th element after being inspired by all these talks. Challenge number 1, learn something today. That's on me. I want to make sure that you leave with really concrete things. Challenge number 2, share something. So my challenge to you is share something that you learned here with somebody that didn't come to this session. We have a whole another half a day and tomorrow morning. Challenge number 3, do something. Take this information, the science, the neuroscience, psychology of exercise on your brain, and improve your brain with it right here in Aspen. And the 4th challenge is really a personal invitation for me. One of the things that has really stuck with me from all the talks is the power of collaboration in moving science forward and creating that next great idea. So my invitation for you is please come and see me and let's have lunch together. If you have anything that you want to share that we can move this information forward. Now let me tell you what my information is first, but I want to encourage any and all collaboration. Okay, but let's start with the star of our show, which is the human brain. This is Betty. She's a preserved human brain that lives in my lab at 25 West 4th Street in New York City. And this is the most complex structure known to humankind. Let me say that one more time. What you see on the screen there and what is in our heads right now is the most complex structure known to humankind. It defines how we see, feel, remember all the wonderful pieces of information that we've learned here at the Aspen Ideas Festival. It is extraordinary. And so with that, I want to highlight 2 key brain areas that we're going to be focused on today when we talk about the topic of the effects of exercise on the brain. The first is the prefrontal cortex right here. You can see on the left-hand side of the slide, that's the front of the brain. Towards the right is the back of the brain. Prefrontal cortex is right behind your forehead, critical for your ability to shift and focus attention. Decision-making also dependent on the prefrontal cortex. Your personality largely is defined by activity in the prefrontal cortex. That's one key brain structure. The second key brain structure is my favorite brain structure I've studied for the last 30 years, called the hippocampus. The hippocampus is not on the surface of the brain, but is actually located deep in the brain. That arrow is pointed towards the brain's temporal lobe. And if I dissect out the temporal lobe in this picture right here, you can see how far down into the temporal lobe the hippocampus is. Hippocampus means seahorse, and you see in the upper right-hand corner, there is a dissected human hippocampus and an actual seahorse. So those early anatomists were absolutely correct. The hippocampus allows us to form and retain new long-term memories for facts and events. So it's working on overdrive here at the Aspen Ideas Festival as we all desperately try to learn and retain all this critical information. You are able to do that because of your working hippocampi. You have one on the right and one on the left. And this reminds me to tell you how I became a neuroscientist. And that brings us to the main neurobiological theme that I will focus on today, which is the theme of brain plasticity. You've heard it if you went to Breakthroughs in Brain Disease session that I thought was so great yesterday. I happened to study as an undergraduate with the discoverer of adult brain plasticity. Her name was Marian Diamond. She was a professor at UC Berkeley, and back in the 60s, she discovered adult brain plasticity. I became a neuroscientist because in the 80s, I walked into a first-year seminar class, and there were only about 15 students, and there she was at the front of the classroom. And the image that I remember of that moment when I walked in is she looked like a neuroscientific Beyoncé. She looked like she owned that classroom. But a very benevolent Beyoncé. She also had a flowered hat box on the counter in front of her. And as she regaled us with the fact that the human brain is the most complex structure known to humankind, she slowly and dramatically opened the lid of that hat box, and with her gloved hand, she pulled out a preserved human brain from that hat box, which blew us away. I mean, I'd never seen a human brain. Nobody had. But what really made me want to become a neuroscientist is the experiments that she then described to us that she did in the 1960s, when it was thought that once your brain reached adulthood, you and your brain reached adulthood, there was no change possible in the anatomy, physiology, and function, because there was no evidence for that. Well, she and her colleagues thought, I don't know if that's true. And she did a simple but elegant experiment to ask whether the adult rodent brain could change. Here's what she did. She subdivided equal groups of rats in two different environments. One she called an enriched environment, where they got free food and water, but they had lots of toys, and it was a big old cage with toys that got changed out all the time. I think of it like the Disney World of rat cages. So much fun the rats were having all this time. By contrast, the other cage was very standard, maybe one other rat in there, whereas the enriched environment had lots of rats, no toys being changed out, but food and water. And if the adult rodent brain didn't change at all, then there should be absolutely no difference in the structure of the brains after 3 months of living, either in Disney World or standard rat cage. 3 months later, she found that the rats that were raised in the Disney World of rat cages, actually the outer covering of the brain, the cortex, was thicker. She was a neuroanatomist, so she was able to measure that directly. And that was the first demonstration of adult brain plasticity. Now, just so we're all on the same page, brain plasticity is defined as the ability of the brain to modify, rewire, and change itself. That's what she showed the adult brain can do. But just for the visual learners out there, let's say you start with a brain that, let's say, needs a little bit of self-actualization. Let's say it starts like this. Brain plasticity shows that with certain kinds of experience, a brain that looks like that can turn into the big, fat, fluffy brain that you see on the right with all the great areas, the beer area, the TV area, all those great areas. That direction is called positive brain plasticity. But in biology, what goes up can also come down. And different experiences can take that big, fat, fluffy brain you see on the right and turn it into the smaller brain that you see on the left, and that's called negative brain plasticity. I regret to inform you that all of us has experienced two of the most common forms of experience that lead to negative brain plasticity. What are they? Chronic anxiety, chronic stress. We know that, for example, PTSD, subjects with PTSD, can actually have a significantly smaller temporal lobe compared to control subjects. But my topic for today is one, not the only one, but one of the most powerful examples that cause positive brain plasticity, that is growth, and that is physical activity, moving your body. Now you might be thinking, well, how'd you get from Disney World to exercise as a main component of brain plasticity? Well, they did experiments to say, what was it about the Disney World of rat cages that caused those brain changes? What they found is all you need to do is give the rats a running wheel in their cage, and they got all of those brain benefits. That's how we've come to at least the early understanding of the power of exercise. Now, I call physical activity the most transformative thing that you can do for your brain today for the following 3 reasons. You get immediate benefits from moving your body. Number 2, there are long-term benefits if you keep that up over a long period of time. By long-term, I mean benefits for the anatomy, the brain's anatomy, physiology, and function. And third, there are protective benefits from regular exercise as we all move into older age. So I'm going to go through each one of these one by one, and because everybody wants the immediate effects, let's start with the immediate benefits of exercise. Now, my favorite way to demonstrate why there are immediate benefits is to show you this graph. Here it is, right here. Okay, this is a graph, and you can look up all the research that went into it from a review paper that I did with a postdoc at the time, Julia Bassio, back in 2017. And this shows all of the different neurochemicals that increase after a single bout of movement. And you can see on the x-axis how long those different neurochemicals stay elevated in the brain. Dopamine, noradrenaline, serotonin, endorphins are going up. There are growth factors. There's cortisol that goes up, but never fear, cortisol is a stress hormone. But it turns out that there are cofactors that get released during physical exercise that isn't stressful that protect the brain from the damage that cortisol can do in chronic stress or PTSD. Okay, so what do you think this what does to our brains and to our moods? Well, first, let me give you my first visualization, something that you can learn, take away from, and that is that every single time each and every one of us moves our body, it's like giving your brain a bubble bath of neurochemicals. And that is exactly what's happening. So that dopamine and serotonin and noradrenaline is going up. And what do you get with that? 3 things. You get immediate mood boost. This is what antidepressants are doing, artificially increasing that dopamine, noradrenaline, and serotonin. That is why you get that immediate mood boost. But that's not all. You also get an immediate, though not long-lasting, temporary increase in your ability to shift and focus attention. These 2 reasons right here, all backed up by science, is why I tell all of my students that when you have a hard lecture coming up, a hard day coming up, go take a walk around Washington Square Park. You're going to get better mood and better focus and attention right before you walk into that lecture. The third benefit that you get is your reaction time, your motor cortex is benefiting from moving your body. Your response times are significantly better. So those are immediate things that you get with just a single bout of exercise. And let me just take a quick poll. How many of you have noticed that you feel better psychologically after a walk? Okay, not surprised here at Aspen. But I would like to do something a little bit different. I want to do an experiment right here in this room. Okay, so everybody pull out your phones, go to this QR code, and you're going to be asked to put in up to 3 words. You can do 1 to 3 different words that describe how you feel right now. Now, using this program, I can't tell who logged in, so it's completely anonymous, but it's going to create a word cloud for an immediate pulse on how the room is feeling. And we'll just, okay, good, 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 beautiful. Okay, Aspen is truly unique, because I've done this hundreds and hundreds of times with 5th graders to adults CEOs to graduate students. Guess what the biggest word in the center of the word cloud always is, except for here at Aspen? What? Anxious? Tired. Everybody puts in the word tired, but here at Aspen, we are happy. But, okay, we're gonna wait for one more minute, and we're gonna do an experiment to see if we can change the quality of the psychological feelings that we're feeling with an experiment inspired by the data that I just went over. Okay, great. That seems to have equilibrated. Now, we're gonna move for just a minute and a half. So everybody stand up. We're gonna do a little tester before I have my DJ back there turn the music on. Everybody come into the on guard position. Okay, this is call and response. So you're gonna do what I do, and I'll say affirmation, and then you say it back. Punches right and left. Go right and left, right and left. I say, I am strong now. You say it. I am strong now. Beautiful. DJ, hit the music. 4, 3, 2, 1. Punch your right, left, left. Don't punch your neighbor. Let's go. I am strong now. You say it. I say we are really strong. You say. I say Aspen is strong now. You say it. Last time. I am really strong. You. New move. Uppercut. Right and left. Right, left, right, left, right, left. I say I am inspired now. You. Again, we are inspired right now. You. Last time, we are inspired now. You. Last move, pull it down, pull it down, pull it down, pull it down. I am on fire now. You. I say we are on fire right now. You. Last time, I am on fire now. You. Done. Okay, give yourselves a hand. Give somebody a high five. Have a seat. Now, we were moving for, I don't know, a minute. Go back to that QR code and be honest. What are those words that are coming up? Okay. Ooh. I'm with you on the out of breath. There's not as much oxygen up here as there is in New York. But no humidity, yes, that is good. Okay, so we still have a very big happy, but energized, I think, really took a really increase that is consistent with a lot of the data that moving your body gives you more energy, doesn't suck it away. So I'm saving this word cloud because I've never had tired even been in here. Nobody's tired. That's great. I love this. Okay, but I think you get the feeling that exercise can be transformative even in small bouts, and it has a particularly profound effect on your mood. So if we go back to the main slides, I want to do a little detour. Great. Going back to brain plasticity, in addition to exercise, because this has been a theme and I've heard some great talks on it at Aspen, I want to add good anxiety to the right-hand side of this slide. What do I mean by good anxiety? Happens to be the title of my second book. And let me just define what I mean by good anxiety and how can it be a positive brain plasticity kind of driver. So good anxiety is acknowledging the fact that anxiety is a normal human emotion. We all have it. I'm not talking about clinical levels of anxiety that debilitate your ability to kind of live your normal life. but everybody has a little bit of anxiety. The top 10 to 20%, clinical anxiety. The rest of us, like me, have regular anxiety. And the important thing to remember is that anxiety evolved in our species not just to weigh us down and to debilitate us, but to warn us. It is a protective emotion. And so how do I get to the protective aspects of good anxiety? And I just want to give you 2 quick steps to get there. First is most of us, when we're not in Aspen, back in our regular lives, have higher levels of anxiety, particularly after the pandemic. And the first step usually is to be able to modulate that, learn how to modulate it. So step 1 is learning to turn the volume down on your anxiety. And we just, as a group, did one of the best things that you can do. Exercise, movement can immediately decrease your anxiety levels. But this is where breath work can also come in. Many of you may know that breath work activates the parasympathetic nervous system, which is also called the rest and digest part of your nervous system. It is equal and opposite to the fight or flight part of the nervous system. So everybody knows how their own fight or flight systems gets activated. Sometimes it just comes at you. Here is a way, and this is the reason why breath work can slow down or decrease that flight or flight, that stress response, because it's directly activating the parasympathetic nervous system. So I have a whole bunch of tools, science-based tools in my book, Good Anxiety, but I gave you my first 2 go-tos. Moving your body, as we did here, beautiful walk outside, go on the one of the forest bathing events that they have here, or breath work. You don't know what kind of breath work? That's what YouTube is for. So many free breath work things that you can, strategies that you can do there. But I really want to get to step 2, and this is what I think the book Good Anxiety is really good for, is that I wanted to, if I argue that anxiety is protective, then I can't just say, okay, here's all the ways to decrease your anxiety. What good is it? You said it's good anxiety. And the idea that I really focused on is, and I leaned into in the writing of this book, is that anxiety, because of its protective nature, can provide superpowers or gifts to you. I talk about 6 in the book. I'm going to give you the first one. Again, this is action-oriented. This is something that everybody can use today. And that is a superpower of productivity, and it works this way. Very common form of anxiety is the what-if list. Even here at Aspen, I'm sure many of us have that what-if list from all the tasks piling up way back at home. What if that goes overdue? What, I haven't done that yet. I haven't thought about that one yet. All those what-if lists. And the superpower of productivity is recognizing that those what-if lists are important things to you. Your job is important. Maybe it's a what if about finances or your family or your relationships. These are all things that are revealing what you hold near and dear to your heart. So the way to flip it into a gift or a superpower is simply by shifting that what if list into a to-do list. And let me share how I use it, which is my what-if list always comes up to me right before I'm going to go to sleep. Trying to go to sleep, get good 8 hours of sleep, and I'm about to fall asleep, and then bing, all the worries of the day come in. And so what I've taught myself to do is I note them, the things that are worrisome from the day, and the next morning I make my to-do list, and I do something for all of them. And so it doesn't keep me up in the middle of the night. I know I'm going to do it. I make a promise to myself. Try that. Turn your what-if list into a to-do list and use those things that are coming up as worries to help direct you towards your action items. Okay, that's just a brief foray into anxiety because exercise is such a powerful tool for anxiety, and I know it's a theme here at this year's Aspen Ideas Festival. But let me go back to our 3 transformative things that exercise can do for your brain. We looked at and experienced the immediate effects of exercise, particularly on mood. But let me go to those long-term effects. And to try and understand, to show you why there are these long-term effects, I'm going to go back to this table. and go down to the growth factor. The thing that gets released when you move your body, one of the many things that gets released, and this is not a comprehensive list, but some of the key ones, is a growth factor called, abbreviated as BDNF, brain-derived neurotrophic factor. This goes out not in any time you move your body. Studies have shown that moving your body where your heart rate is going up, that is aerobic activity, is particularly effective at increasing the release of growth factors. How does it get released? Well, we know a little bit about that mechanism. Muscles being used release a precursor to BDNF that goes through the blood-brain barrier and goes into the brain. The liver also releases a precursor of BDNF that goes into the brain. And even your fat cells, when you're moving your body, of course, also moving your body movement, aerobic movement is stimulating the release from your liver, from your muscles, and then finally your fat cells. So all of these pathways are leading to release of precursors of BDNF that go into your brain. Where does it go? To my favorite structure, the hippocampus. And what does it do? It helps shiny new hippocampal cells grow. That is the job of BDNF in adulthood. So remember what the hippocampus does. It's really important for learning and memory. How many of you want shiny new hippocampal cells in your hippocampus right now? Yes. So I've just told you the secret. Moving your body so that you, that get your heart rate up, aerobic. And let me remind you that power walking can get your heart rate up. You don't have to run a marathon. That will get more BDNF flowing. Now, it doesn't happen immediately. Just one molecule of BDNF doesn't pop open a new hippocampal cell. This is long-term. And think about how much BDNF do you want to be watering your left and right hippocampus over your lifetime. The more you water it with BDNF, with aerobic activity, the more cells are being grown. And studies have shown that the new hippocampal cells that get born after adulthood are like kind of teenage hippocampal cells. They get integrated in memory circuits better. They work better than the ones that have been in your hippocampus since you were born. So that is BDNF and the hippocampus. What about reminding you where the hippocampus is, what about the prefrontal cortex? No new neurons being born in the hippocampus with long-term exercise. But there is evidence of growth in the prefrontal cortex. We think it's from the production of new connections of the cells that are already there, new synapses in the prefrontal cortex. What we know is that long-term exercise in humans has led to an increased size in certain prefrontal areas. So there's growth in both of these areas, and evidence that the function is better in the hippocampus and the prefrontal cortex with long-term exercise. Let me just share with you that overall, if you survey all of the work that has been done on the effects of exercise in the human brain, the most common effect from long-term exercise is improved ability to shift and focus emotion. That is, the prefrontal cortex seems especially sensitive in the good way to long-term effects of exercise. So you get better growth, more cells or synapses, better function. What about the last element? Okay, so protective element of the brain. So what I didn't tell you is these two areas that I've highlighted, the prefrontal cortex and the hippocampus, are also two of the areas that are most susceptible to normal aging, as well as neurodegenerative disease states. You might know that the hippocampus is first affected in Alzheimer's disease, the most common form of dementia, which is why memory impairments are so common in early Alzheimer's cases. It's because their hippocampus is being filled with those plaques and tangles. Cells are dying. So, why is exercise so transformative? Moving your body aerobically is not curing aging or neurodegenerative disease states, But you can think of it as a supercharged 401k for your brain. Because every time you're moving your body, especially aerobically, you get that BDNF up, you are making your hippocampus and prefrontal cortex big and fat and fluffy. Again, not curing the disease, but you are enhancing these two areas that are most susceptible, and in that way staving off the effects of aging and neurodegenerative disease states, which is very simple. Once you kill too many cells, you start to see the behavioral effects. So imagine a lifetime of active person watering their hippocampus and prefrontal cortex with growth factors all their lifelong time. And they might have genes for Alzheimer's disease. My father passed away with Alzheimer's disease, so I know that is in my family, which is part of my motivation to work out aerobically all the time. That is the power of the protective elements of exercise for your brain. Now, I want to end with answering the 3 most common questions that I get from these talks, and this will also share some more data. Okay, so what are the answers to my 3 top most common questions? Question number 1, what is the least amount of movement I need to do to get some of these effects? I know some of you are already thinking about it. The answer is 10 minutes of walking has been shown to significantly decrease depression and anxiety levels. Think about that. You don't need anything, just your shoes, just your body. Go on a 10-minute walk can significantly decrease depression and anxiety measures in psychological tests. So that's the first most immediate. All of us has probably already walked 10 minutes today. But here's where the mindset comes in. Knowing that you can apply and use your 10-minute walk strategically in your life. That's question number 2. Okay, question number 1. Question number 2, what do I have to do to see all those things you were talking about? Shiny new hippocampal cells, more synapses in your prefrontal cortex. Is that 10 minutes of walking too? One says hopefully. The answer is no, those were the long-term effects. But here's a recent finding from a study that I did in low-fit people. These are people that were working out less than 30 minutes a week for the last 3 months, and we asked them to work out 2 to 3 times a week aerobically for 45 minutes. They ended up working, I think it was 2.4 times a week for this 45-minute aerobic workout. And so we can say now that for middle-aged people, they were between the ages of 30 and 60, 2 to 3 times a week aerobic workout. What did we see? We saw improvements in mood. We saw improvements in recognition memory, dependent on the hippocampus and related areas, and significant improvements in prefrontal function. These were all behavioral measures. We didn't go in and measure using MRI. In fact, I don't think we would have seen anything. The effects were more subtle, but the findings were more impactful. Their memory performance got better. Their ability to shift and focus attention got better. And so that is kind of where we are in the state. One of my goals as a neuroscientist was to find that prescription. You're 18 years old. What exactly do you need to do to improve your focus, your prefrontal function, your hippocampal function, your mood, and then go up the age range? We don't quite have that. But now, being in charge of 9,000 undergraduate students, I have a big population to look for, and we're doing those experiments right now. And the third question that I will answer is, how do I get motivated to exercise? This is a very common question and maybe less common here in Aspen. But my answer is, see the next slide. I'm a nerdy neuroscientist that is motivated by science-based findings. And here is my and hopefully your exercise motivation, all coming from all the things that I've spoken about today. Number 1, every time you work out, you are giving your brain a bubble bath of beneficial neurochemicals. That is a motivation that I use every morning, even when I don't want to work out. This is good for your brain. It is scrubbing your brain, and it's a beautiful metaphor that you could share with friends that may not want to do it, or friends that you want to include in your workout. Motivation number 2, moving your body regularly will help you grow shiny new hippocampal cells, improve your memory function, and new synapses in the prefrontal cortex, improving your ability to shift and focus attention. Am I interested in this as a dean of students, where their 2 main brain functions that I'm trying to focus on are memory and focus? Yes, I am. So my motivation is to give them lots of opportunities to move together with me. Okay, and number 3, moving your body regularly is like a shield that is protecting your brain from aging and neurodegenerative disease states. Yes, this will not change the genes that you happen to have, but it is enhancing and enriching these 2 key brain areas that we know are very susceptible to both aging and neurodegenerative disease states. That is the hippocampus, important for memory, and the prefrontal cortex, important for focus and attention. Okay, so I'm going to end with that Aspen Brain Challenge. I hope you learned something. Bubble baths, BDNF, growing new hippocampal cells. I hope you share something with your friends, your family, somebody you meet here at Aspen. I hope you do something that is changing your brain, whether it's using the changing the what-if list into the to-do list or adding more exercise. I think people get too hard on themselves. They say, oh, I only walk. They say it to me like it's embarrassing. Walking is great. Walking is really helpful, and it's a great start, and it will stick with you for a lifetime. But everybody has the capacity to increase their movement in their life in a way that works for them. So the challenge is to be creative in the way that you bring more exercise in your life. And I'll add my 4th challenge is, if you have a company or an idea or a finding or an organization that can collaborate and enhance some of this work that I'm doing, please come and see me. And I will end by saying thank you, and we have plenty of time for questions, so thank you so much. Okay, so we're going to start here and go there. Question number 1 here. Here? Okay, we'll go there first. Sorry. Well, you can be second.
Wendy,
yeah.
So we've discovered that seems to be a spike in BDNF with other interventions like mindfulness meditation and psychedelics, and there's an association with a reduction in what we call the default mode network, which is associated with kind of self-referential thought and ego.
Yeah.
Are you aware of any studies, or do you know whether we see also a reduction in default mode network with exercise interventions?
That's a great question. I can't think of off the top of my head whether that has been the focus. Because of all the rodent work, there's so much interest in hippocampal function and prefrontal function. I think that I haven't, but that would be a great study to do. And I think it's really important to emphasize that other brain boosting and activities like mindfulness meditation is also on the list. I just focused on exercise and for the same reasons. They are using shared mechanisms that are all good for your brain. So thank you for bringing that up. Yes, question number 2 is right here, and then we'll go 3 and 4.
So I'm curious about where high-impact interval training fits into this, because there's been a lot of research on that, and seems like it's in some ways more efficient than regular aerobic exercise, and then just weight training without necessarily additional aerobics.
Yeah, that's a great question. So high interval training is very efficient cardiovascularly, and so sometimes there's a little bit of mix-up, just because it's great that it's so good for your heart, your cardiovascular system. That doesn't mean that it has better effects on your brain. You have to study that directly. So I can't answer the question is the most efficient workout for your muscles and your cardiovascular system. Also, the most efficient workout for your brain. Yes, a few studies in the brain benefits of exercise have used high-intensity interval training, but most of them have used, just regular, running and a treadmill walking or exercises like that. So we don't know the answer to that. You asked another very common question, which is what about weight training? And the evidence is a little bit mixed for weight training, mainly because there's not nearly as many studies on weight training as there is on aerobic activity. It started first. And I asked the question, is the effectiveness of weight training correlated to the amount that it increases your heart rate? It does increase your heart rate. So we don't know the answers to that. Am I saying, no, don't weight train at all, don't do high-intensity interval training? No, work out as you like. Generally, moving your body is great for your brain. I hope that we, as a field, will get to that prescription so that we can rank. Everybody wants a rank. I hope my favorite exercise is way up on the list. We don't quite have that yet, so the encouragement and the data suggests any way you want to move your body, walking, power walking, go for a walk with your dog is beneficial. Yes?
Thank you. Thank you so much. My name is Whitney Cordova. I am finishing a PhD in epidemiology at Indiana University, and my research questions are usually on the intersection of physical activity and mental health.
Yes.
And what we found is that whether it works or not, and for which psychiatry disorders or not it works, depends a lot on what dimension of physical activity we're working on and how it is measured, right?
Yeah.
I would like to know from your experience, what will be outcome measures that we can use in research to move from the understanding that this is helpful, right, that this works, to how can we potentially change the way we practice, the way we prescribe exercise, and the way we treat patients with different mental health issues.
Yeah.
What will be those outcome measures of interest to say, hey, we know this works from a physiological standpoint now, how do I prove to you that this actually works from a health economics standpoint?
Right, that's a great question. And I would say that we have some of those potential measures already in some of the standard mood questionnaires that could be life-changing for people with depression or anxiety. And what we don't have is, as I was saying, the precise prescription. It's not that helpful, just walk more. How much do I need to walk? When is the timing that's good for me, and I have a busy life. I can't walk all the time. So, but I think the measures of depression index, anxiety index are a great starting point, and if we use that, because there are so many, that is one of, together with the benefits of exercise on focus and attention, those standard measures of focus and attention are some of the most common findings in the human literature. So I think it is kind of encouraging all the researchers out there to get more practical, to be able to move it more towards prescription than it is right now. So that's what I would say. Yes?
Hi, Dr. Suzuki. Audrey Davis, Cancer Support Community. Thank you for your thought leadership in this space. I'm thinking in the context of people who have cancer.
Yes.
And the fact that we encourage them to get moving and things like that. Does environment play a role at all in terms of the exercise environment and the benefits that you see on the brain? So if someone is limited to the hospital setting versus exercising indoors at home versus needing to get out, but maybe is experiencing other symptoms or side effects that might prevent that, how important is environment?
Yeah, I mean, I think generally exercise environment is so important, even if you don't have cancer. How many excuses have you heard for, I don't want to exercise? Oh, I don't feel like it. It's not, I don't like this gym. The color on the wall isn't good. So yes, it is very important. But was it this morning? You were there at the online health talk about meeting people where they are. you have to ask. I ask my students, what would you like to do? How do you want to try and improve this in a way that, turns out they don't like to come to my lab and run on the treadmill. However, my recent collaboration with the University Learning Center, the Tutoring Learning Center, is taking them out before they go on their tutoring on a walk together. So they start the process there and continue. That they're willing to do. It's with their friends, and that just takes work to be able to do that. But to answer your question, yes, the environment works. Too hard, too easy, not good. Also, the social environment. So all of that needs to be taken into consideration to make it effective. I could prescribe all the time. I give this talk all the time. How come more people, me and Michelle Obama, didn't get everybody moving? But part of that is finding those structures that work for our society. Okay, there's one back there.
Hi, thanks for a wonderful presentation. My name is Cynthia Hazel. I am a community health practitioner with a nonprofit here in the Denver metro area. I have collaborated on an NIH grant that is looking at improving exercise maintenance amongst Black adults. And just to add a little bit of context, about 60% of Black adults initiate exercise, but that number dramatically reduces to about 25% within 6 months. Yeah. So our study is focused on researching what are some of the culturally responsive ways we can help Black adults maintain exercise once they start. Yeah. So my question to you is, I know culture plays a big role in the types of exercises that people initiate, and also what is accessible depending on your socioeconomic status. What are some of the tips that in your work you have come across that has been beneficial, especially for low-income folks who are interested in taking up exercise but have environmental and maybe cultural barriers?
Yeah. Well, I'm just going to go with something that we talked a lot about, which is walking. Walking is very, very effective, especially for the mood, and you can ramp it up and down depending on your physical abilities. Power walking can get aerobics up. But I'm not saying, that's my answer, that'll solve everything. There are cultural things. If you can go into social groups, church groups, other hobby groups that are particularly engaging for a particular community, and get that to be integrated into that social environment, add it to something that is already drawing them together. And I think that's what I try and do with the students at my institution. It's a test of creativity, but it's not unsolvable, and you just look for the things that are already attracting your population to come together and find something that is and use movement. But all of us doing exercise studies are grappling with those same things. So happy to continue to talk more about how we can come together and find those strategies that work best across all communities. Great. Yes. Yes.
Hi, I'm curious what the differences are if somebody is a lifelong mover or exerciser versus kind of being, little dormant in their early years and then doing this later. Yeah. Do you still see the same improvements, or should this really be lifelong stressed?
So here's what I could say is that they did studies in older people, 60 and over, that were not walkers, and they asked them to walk regularly all year round. And those that walked 3 times a week or more in that time period, I think it was over 6 years they did this, reduced their chances of developing dementia by 30%. These were people that were not regular walkers. I think everybody can imagine, I start there because I think everybody imagine, if you trained for the Olympics young and you keep doing it, you have a big fat fluffy hippocampus and prefrontal cortex, and that absolutely is beneficial, and that has been played out. We haven't done randomly controlled studies, but yes, there's correlations. The more you are regularly working out, the better your brain function is, the least likely you are in developing dementia. But that study always sticks to me. walking 3 times a week can reduce your probability of developing dementia in, between 60 and 70. Everybody can walk 3 times a week. That is why I call it the most transformative thing that you could do for your brain. And there's time for one more question. And if not, oh, there's one way in the back. Yeah. What is my physical regimen? So I happen to be a morning person. I like to wake up early. I do a meditation. It took me a long time to find one that really stuck. I happen to do one that is, it's called tea meditation. It's meditating over the brewing and drinking of tea. So that happens for 30 to 45 minutes, and then I work out. For 30 minutes, I try and do a cardio strength workout. I'm over 50, so I like to include weights in my workout, and weights plus cardio just ups the cardio, so I get double boost of cardio. And I like to do it in the morning because for me, it's not interrupted nearly as much as if I try to do it at lunch or after work. But that is my regimen. I try and do it 7 days a week, although I admit the altitude really got me. So anybody that was near no, I didn't do it because I was trying to save my energy for this talk. But I made it through, so it's good. Thank you so much. Oh, wait. I have a little surprise for all of you. This is like a de-stressing brain. Oops. Oops, okay. No, I have to throw lower. Sorry. Woo! Okay, don't let me hit you, and don't let me damage your. Okay. Okay. All right, there you go. Thank you so much.